Hey everyone, this is part 2 of Newton's second law. We're going to explain the relationship between mass, force, and acceleration. So vector versus scalar, if we have a physical quantity that has magnitude only, then it would be scalar. If it has magnitude and a direction, it would be considered vector. Because force and acceleration are both vector quantities, mass is a scalar quantity. So we want to think about that when using Newton's law. So acceleration is a measure of change in motion and is defined as the rate at which the velocity of the object changes. Changes of direction at constant speed is also acceleration, which does not happen without an unbalanced force. An example would be a car racing around the oval of a racetrack at a constant speed. It is accelerating due to constant change in direction. The applied force causes them to accelerate by changing direction. So increasing speed, decreasing speed, changing direction. Acceleration due to gravity is always constant. It's proven by the fact that the ratio of net force to mass remains constant. We can prove that mathematically. Mass has a direct relationship with force. In this instance, the force we are experiencing is weight, force exerted downward. On Earth, a free-falling object has an acceleration of 9.8 meters per second squared downward. It is a vector quantity because it has direction downward. This numerical value for the acceleration of a free-falling object is such an important value that it is given a special name, acceleration of gravity, and is represented by the letter little g. When an object falls on Earth, like our apple, the object's acceleration will be 9.8 meters per second squared. All right, in example problem number 1, using Newton's second law, we can predict the relationship between force, mass, and acceleration. We know that if we have a bowling ball and a tennis ball and we exert the same force on both objects, the tennis ball will likely travel faster than the bowling ball. Newton's second law proves this to be true. Let's assume the bowling ball has a mass of 5 kilograms and the tennis ball has a mass of 0.06 kilograms. We will exert 10 newtons of force on both objects. Using the formula for Newton's second law, the calculations would look like this. For the tennis ball, force equals ma, 10 newtons applied to 0.6 kilogram tennis ball times acceleration. We're trying to find a, so 10 newtons divided by 0.06 kilograms to isolate that quantity would give us an acceleration of 166.6 meters per second squared for acceleration. Bowling ball, using the same equation, 10 newtons applied for force equals a mass of 5 kilograms times acceleration. 10 divided by 5 is going to give us acceleration of 2 meters per second squared. So you can see the tennis ball accelerates much faster than the bowling ball. So what happens when we change the force exerted? We're going to use the same example with the bowling ball and the tennis ball, but in this case, we will have different forces exerted and calculate the acceleration. For trial 1, we're going to exert 5 newtons of force, and trial 2, we're going to decrease to 2 newtons of force. So trial 1, the bowling ball ends up having 1 meter per second squared acceleration, the tennis ball 83.3 meters per second squared acceleration. And then when we decrease the force, we can see that we actually decrease acceleration as well. We've kept mass the same. So force and acceleration are proportional, directly proportional, as long as mass is constant. So when the force was reduced, the acceleration decreased for both objects. This is called a directly proportional relationship, that as one variable, force, is changed, the resulting variable will change in proportion to the first variable. Essentially, if the mass of an object is kept constant and the force is decreased, the resulting acceleration will also decrease, which we saw in our example here. Quick summary, we can calculate the force, mass, or acceleration of objects that interact using Newton's second law. So if I'm given 2 out of 3 variables, force, mass, or acceleration, then I can find the missing variable. Thanks for watching. Good luck.